Let's solve this complex trigonometric integral step by step. We need to evaluate the integral of cosine 8x minus cosine 7x divided by 1 plus 2 cosine 5x. Our first step is to rewrite the denominator using a trigonometric identity. We can express 1 plus 2 cosine 5x as a ratio of sines. This allows us to rewrite our integral as the cosine 8x minus cosine 7x times sine 5x over sine 5x plus sine 10x. Next, we'll use the product to sum identity for the difference of cosines. The cosine 8x minus cosine 7x equals negative 2 sine 15x over 2 times sine x over 2. Substituting this in, our integral becomes negative 2 sine 15x over 2 times sine x over 2 times sine 5x, all divided by 2 sine 15x over 2 times cosine 5x over 2. The sine 15x over 2 terms cancel out in the numerator and denominator. This simplifies our expression to negative sine x over 2 times 2 sine 5x over 2 times cosine 5x over 2, all over cosine 5x over 2. Using the double angle formula for sine, 2 sine a cosine equals sine 2a, we can simplify this further to negative 2 sine x over 2 times sine 5x over 2. Using another trigonometric identity, this is equal to negative cosine 2x minus cosine 3x. We can rewrite this as the integral of cosine 3x minus cosine 2x. Finally, integrating each term, we get 1/3 sine 3x minus 1/2 sine 2x plus c. This is our final answer, which matches option B. Let's verify our answer by looking at the options again. And that's how we solve this complex trigonometric integral. Thank you for watching.